Assalamu alaikum everyone. So today we are going to discuss an interesting topic, okay? And mainly we are discussing RAG and retrieval augmented generation. And you all know about RAG and these techniques that now enable businesses to do like chatbots and QA assistants, and different applications. And actually every day we see like new technique comes to RAG, like we start from self-RAG, collective RAG, adaptive RAG, and then we have that HTML RAG and different types of RAG that all trying to enhance the capabilities of this system or pipeline in order to be able to receive the query efficiently, pass it through the embedding model. We could retrieve the exact information that the user is asking about, and through the prompt and LLM we can generate that answer for the user. But if you notice, when we deal with this, we have some source data, right? And these data are actually docs, CSV files, or PDF. And what actually I mean by this is all are text data, right? This is what we are trying to process. But the case is in real life when it comes to, let's say, businesses and some important or production level systems that not only process that text, they might get they want answers from images, sometimes from tables or from charts, right? So today I am going to show you a new technique of RAG, and we call it Vision RAG, okay? And Vision RAG is come to solve these issues, to process the data, which is unstructured data, like images, tables, and other type charts and different things. So it can answer user question based on the most relevant table or images, and then extract the answers, pass it through LLM to generate the answer, right? And actually we have seen some traditional approaches, okay? We have some traditional approach to do so. So one of the techniques that we use to solve this issue is to parse these images, okay, and tables from the document, and then we use either OCR models or vision language model, okay, to solve this issue by embedding them or embedding those captions after the models or the layout detected by the OCR, and then we embed these captions and we make it as chunking, and it will be stored directly to the vector store, and then we can continue with the RAG or by getting the similarity score and get the answer. So converting the image into text, and then let's say based on markdown, okay, and like there's a potentially huge issue with this approach, right? You will lose a lot of information actually here in this layer when you convert this. And also the description is based on the LLM, right? Or the capability of that OCR model, or based on the vision language model, using your prompts that you use to extract, especially when you deal with VLM. So you need that strong prompts to be able to, or many tests to be able to achieve what you want to do, okay? So there is like, after this is traditional by the way, and after these traditional concepts, we move to something called 𝗏𝗏𝗏𝗏, and I think some of you are aware of doing so. This idea is actually a bit smart, but still it has like some limitations, okay? So actually here we takes images of pages and directly we encode them using vision encoder, okay? By this vision encoder, we can create the embeddings, okay? And then you can notice here, it will be converted into it will be converted to multi-level, okay? We end up with, after the vision encoder, and the LLM that will take the prediction, and then we generate these vector stores based on the image based on that vision encoder. We end up with multi-level embeddings for each of the batches, okay? And this, of course, will make like the memory requirements like huge. And actually, most of the existing vector stores doesn't support the multi-level representation, let's say, for the batches of the document that we pass through the vision encoder, okay? So neither the traditional RAGs or this idea or the 𝗘𝗶𝗃 idea doesn't give that good, let's say, application for the unstructured or image table-based search. So here we go with a new idea that came up recently, and when Cohere introduced Embed 4, right? Embed 4, it's called Embed 4, and let me show you here. If you go and you start reading about this amazing blog, you can see they introduced a multimodal search for businesses, and you can read throughout this article and see the performance of that embedding model, okay? So the idea here is we are using a multimodal embedding for multimodal search, okay? And actually, as I told you, the multimodal embeddings is achieving the state-of-the-art results on vision-based retrieval. And it's like, it has a cost, of course, but it is like overcome the limitations that are in previous methods like 𝗘𝗶𝗃 methods, okay? And here you can use these embeddings directly with the vector store, and easily it will be like normal embeddings that are extracted from these, and you can store it in any vector database, right? And then you can use all these and create all these embeddings of the images of all the pages that you need with a document or set of documents or set of charts or set of tables, right? And then you can pass the query along with the retrieved images to a multimodal, right? Multimodal LLM. And now we have seen the increased development in these multimodal LLM. And the first people who come to this is Google, right? With Gemini. And now we have seen amazing performance, let's say, when we use Gemini 2.5 and Flash and different models. So Gemini will be responsible to generate these responses, okay? So actually what I did here, I pass it Arabic document from a dictionary book. And then I embed these using Embed 4 from Cohere and store it in a vector database. When I ask a question about meaning of a word that exists in one of these documents, and especially this one, it could be able to retrieve that document using the cosine similarity, and then this, along with my query, will pass through the multimodal LLM that can receive the image and the text, and then it can give me the answer easily, okay? So if you are interested to see this, I can show. Okay, now let's see the video, and let me explain the code for you. So we start with initial imports, okay, and then we need some helper function that can resize the images, okay, and we need to get this format. It is acceptable by the embedding model and also by the Gemini model. We do a simple function here just to resize the image based on the pixels or the max resolution for the images that I want, and then we convert it to base 64. And as I told you, it is acceptable by different models. Now, I am interested in different images, okay? So I have this one, I have this one, and this one, and different charts, okay? And all I want is to pass this to the Embed 4 in order to generate embeddings, right? And if you notice here, what we are doing is we're calling the the package that we just installed from the install Cohere, and then we can use their embed function here, passing the model, the multimodal model, and then it is like for search documents, and we can give it all the whole document that we have, and then it will be simply like generate those embeddings. Okay. Then for the second part, what we need to do is the search part. Okay, so we need to search, allow us to find the relevant images for our given questions, like using the embedding, right? And we also like specify here the search query. So what we need to do is to find the cosine similarity between the query embedding and the document embedding that we have. Okay, and if it is like the most prevalent one, it will be extracted, or it will be passed to the as an output using this argmax function, and then it will show the image for the user, right? And in order to have like a good answer based on that questions with good knowledge, we can use Gemini with a simple prompt here, and we just pass it to Gemini 2.5 Flash in order to get that answer. Okay, so once you ask about different questions here about the chart, you will be able to generate this. So this is the code quickly, and let me just show you what I have done so far. So if you go to my website, I just allowed here like a 24 hours testing of a multi-rag that I have done, and this is actually using this one is using like radio app that I have done just to test. Okay, and actually what I have did here is, let me show you a quick thing I have done here. So like here I have passed some image. I'm sorry for the screen because I already like did it to take this portion of my screen, but anyway, here I am asking the question, and here I have the document, right, that I pass it to the model in order. This is the embedded one, and it will be able to like give me the most relevant one, and then with the response here. So I like a recommendation for you. You can visit it and you can try it. It is like it will last like 24 hours, and then I will remove it. But this is just like to showcase the issue, and I really got impressed by this idea, because combining the multimodal embedding with the multimodal LLM, it is about to reach like good capabilities in different languages when it comes to vision, and this is very important part for businesses to develop. Okay, so that's all, and I hope this explanation is easy for you, and thank you.